average. So if you look at this page here on your handout, we are dealing with the information on state A.
Recording?
Start.
Yep.
Okay. So we are dealing with this information for state A. Remember, each value we are using this note. Either you can do it as capital X or uppercase X or lowercase x. Either way is fine. So let's write down all these values first. So that will be the very first column. We have 28, 23, 26, 25, 27, 26, 24, 28, 27, 26. So we write down all these values in the first column. Then the next thing we need is the mean. So we add all those values and we calculate the mean. So the next one will be x bar. And x bar, when I calculated that, I think I'm right, it came out to be 26. Okay. So we write down 26 for right next to these, each one of these numbers. Next one, remember this x minus x bar? That is, we are at this stage we are trying to find out how much these numbers, how much they are deviating from the mean. So that's why we are doing this x minus x bar. So 28 minus 26, that's 2. 23 minus 26, minus 3, this one is 0, this is minus 1, plus 1, 0, minus 2, plus 2, 1 and 0. Now we do have several deviations which has a negative sign. We have to get rid of that negative sign, so we square it. So x minus x bar square, we get here 4, 9, 0, 1, 1, 0, 4, 4, 1, 0. What do we have? And once we are done with these, then we add all these things up. So it's sum of x minus x bar square. So if we add everything up, we get 24. So what is the formula? This is the formula we are going to use for variance. Remember, variance is s squared. Just keep it as, let's keep it simple, s squared. Forget about these. So variance s squared, standard deviation, square root of variance s squared. So we are going to write s squared, that is the variance, equal sum of x minus x bar squared divided by n. So we have 24, our n is, how many values we have? 10. And that is 2.4. So our variance is 2.4. So this is the difference between variance. If you look at the last two lines of this page, that is the difference between variance and mean deviation. Again, just to recap, First column, we write down each value we have been given in the data set. We write down those. Once we are done with these, second thing is we calculate the X bar, the mean. So we write down in the next column, we write down the mean for each one of these values because we need to see how much each value is deviating from the mean. So we write down the mean here in the second column. Third column, that's this state, X minus X bar, that is the deviation for each value. And we also call it mean deviation because we are comparing, looking at the mean, we are trying to figure out how much it varies from the mean. If the value is higher than the mean, then you have a positive sign. If the value is lower than the mean, then you have a negative sign. So we look at X minus X bar, we calculate the distance between these two values, all 10 of them. Then we have several deviations which has a negative value. We cannot deal with the negative value, we have to square it so that we neutralize that negative. So we square those. Once we are done squaring these, then we add all those things up and we use this formula. And the formula is S squared equals sum of X minus X bar divided by N. And this is what we get for our variance. So 2.4, that's our variance. So what is our standard deviation? So we can write therefore S equal square root of S squared equals square root of 2.4 where is the square root? Where is the square root? So square root of 2.4? Square root of 2.4 is 1.0?
1.55.
1.55, yeah. 1.55, I think I came, next page, if you look at it, I had 1.54. Yeah. Okay. So, this is the standard deviation of the data we have from state A. That's all we have so far. Now, if I am giving you this kind of information, and then if I'm asking you this question, between state A and state B, which data is more dispersed, meaning dispersed around the mean? Which data is more dispersed than the other one? So what are the things you have to do? Anybody, take a guess. Which data is more dispersed? We measure that dispersion in terms of standard deviation. Remember this, if you look at this value of standard deviation, the higher the value, the more dispersed the data.
I just have to figure out what state B is.
So we haven't done that yet. So now we have to do it for state B. Exactly the same thing we will do for state B, and then look at what standard deviation we get for state B. Then you compare the values of standard deviation between state A and state B and see whichever is higher. The higher the value, the more dispersed the data is. Are you guys with me? Okay. So anybody wants to do that for state B?
You already did it for us.
Yeah.
Well, I did it for you, but I didn't show you the calculation.